Okay, this is video 4, and I thought I'd do some turtle graphics stuff. So here's import turtle from turtle import star as usual, and then this is a square, except that the square is drawn above where the turtle starts instead of below. So let's try and do that. Square up, scale factor 100, and that's because I didn't do this. You have to run that file to get the things in it to be defined. So let's see how that came out. So there it is. Here's the cursor, and it goes around like that. So that's what I wanted to get. So I've got that nice packed in a square up function. And then I want to try and do on the sides of, take a square, on each side of the square, construct another square of the same size. So let's see if we can get that to work. Let me run it first so that we can see what it's supposed to do, and then we can try it and see if it works. Okay, so let's try 4 square R 100. Okay, 100. So let's see if we can find the picture. So we have this central square, and then on top of each, I constructed a square on top of it, a square to the side of it, square to the bottom, square to the left. Okay, so that's about what I said I was going to do. So let's take a look at that and see how I did it. Okay, so if you draw a foursquare, if you draw a square up R, then everything's fine, except the next square has to start at the end of the bottom side of that square instead of the top, and instead of the beginning. And how do you move? We want to move the turtle. We want to make sure sure we don't leave any marks that we didn't intend. So we got here pen up. Think of the turtle lifts his pen off the paper, and then forward distance R, and then pen down, and then rotate 90 degrees, and then you're doing the same thing all over again from here, and you're doing the same thing all over again from here, and you're doing the same thing all over again from here. Okay, well, that's kind of messy typing all that over and over again. So you can, one way to compact that, of course, would be to find a function. We're repeating this code, square up, pen up, down to right 90. So we just copy that code into a function utility function, and then we can get the same result by calling that thing 4 times. So let's try that just to make sure we're convinced that that works. So that's 4 square 2. And if we look for that, there it is. We drew it again, so that was satisfactory. And then let's look down here. So I want to erase that, so let's say exit. Okay, well, it maybe seem kind of silly retyping this thing 4 times, and after all, what if I had to do it 10,000 times? Well, there's of course a way in a computer program to repeat something a certain number of times, and in Python that's called the for loop. So the sort of simplest thing would be for I in range 4 starts a block. Let's just do print I. Okay, so first I was 0 and it got printed, and then we went to the top of the loop and it got incremented to 1, and then it came around and printed it, and then 2, and then 3. So you'll notice that this thing is 4 things, which is what we wanted, but this range 4 thing is something you're going to have to get used to. Namely, if you do range n, then that is the same. That gives you the integers in the interval n. 0 starts with and ends at n not quite, so it ends at n minus 1. So it's open on the right. So there's a reason why they do it that way, but it is something you have to keep track of. It's sometimes annoying. This thing about starting lists at 0, that's a programmer's thing. If you tell a programmer a list starts at 1, they'll object. Since I teach linear algebra, I don't really object, so I don't know. It doesn't matter as long as you're consistent. Okay, so by the way, what happens if you type range in here? Name n is not defined. Range 6. Range 0 to 6. Type range range. I guess that makes sense. Okay, so we know how to easily repeat something 4 times. Back here like this. Namely, we can do it like this. For n in range 4, that'll go around the loop 4 times, execute that function. So this ought to do it. I have to execute this, I'm sure. So let's try 4 square 4. Scale factor 100. And there it is. Okay, so that made sense. But it's not necessary to have the intermediate function util. We can just repeat a block. So in our last version here, 4 square 4, for n in range 4, so it's going to go around the loop 4 times, and then this whole block gets repeated. So I can just copy that whole block that I want repeated in there, and it will draw it. Okay, so that should do it. Let's try 4 square 4. 4 scale factor 100. This is probably going to do the bad thing. Oops. All right, exit. Four square. 100. Yes, that's again because I have to execute the script over here to get the things in it to be defined. Okay, that looks good. So that'll work pretty well as far as graphics goes. And of course I can it's possible to use the well, I'm not exactly sure what I'm supposed to do now. I did iteration and I did these functions. So I'm going to give you a handout on doing a problem with polygons using this sort of stuff. And so that should be fairly easy. But it'll be some nice pictures. So let's stop this, exit. Okay, hang on a second.